So hello guys, welcome back to another video. So today our gate 2024 DA exam paper is being conducted and we get the details paper analysis. We have get the some memory based questions and we have to do it after some time. So we get 4 question to probability statistics in 1 marks and 6 questions in the probability statistics 2 marks. In linear algebra 4 question in 1 mark, 2 question in 2 mark. Similarly, calculus we get 2 question is 1 mark and 4 question is 2 mark. So approximately we can get 21 question. We get from the math portions and approx around to 35 to 37 marks. Approx 37 marks are came from math portion. Did 4 questions in 1 mark in DA paper data structure and 4 question in 2 mark in DA. Similarly, algorithm 2 questions in 1 mark and 4 question in 2 mark. So similarly, these 16 questions are came up to data structure and algorithm. So the data structure and algorithm from DA paper also conduct most of the weightage of this paper. Then DBMS and warehousing we get 4 question of 1 marks and 3 question as 2 mark. Then machine learning we get 3 question as 1 mark and 4 questions are 2 mark. And artificially intelligence we get 2 question as 1 mark and 3 questions are 2 mark. And we get general aptitude 5 1 mark question and 5 2 mark question. So these get around the 100 paper marks distribution. And from 21 we get any type of question. MCQ we get 28 and MSQ multiple select question we get 16. So we get some questions analysis in this video. So you can join. So we get a one question related to the limit. So limit extending to 0, ln 1 plus x square cos x by x square. So for that we have to apply the x value over here and we can get, so ln 1 plus 0 into cos 0 by 0. So ln of ln of 1, so cos 0 value is 1, so ln of 1, so ln of 1 means 0, so we get 0 by 0 form. So previously we can calculate many things that if we get 0 by 0 form, we apply L'Hospital method. Apply L'Hospital method for that. So if we apply L'Hospital method, so first we apply log formula over there to simplify this. So ln of 1 plus x square plus ln of cos x upon x square. So we know that ln of AB, so we can get ln of A plus ln of B. This is a basic formula. So then we can apply the, if we apply L'Hospital's method, so L'Hospital method will do that. So the numerator and denominator we get first times of derivative. So we get 1 upon 1 plus x square into 2x plus 1 upon cos x 1 upon cos x into minus sin x cos x differentiation upon 2x. So if we separate these two terms, so we get limit extending to 0 2x being cancelled out, 1 plus x square plus minus sin x upon cos x into 2x. So from here we get limit extending to 0, 1 by 1 plus x square minus, we can write this type of sin x by x by 1 by 2 into cos x. So if we apply x is equal to 0, so we get sin x by x. Over there we get the values as 1. So we get 1 by 1 plus 1 square minus 1 by 2 into cos 0, we get values as 1. So 1 minus 1 by 2. So 1 minus 0.5. So answer of this given question is 0.5. So the answer of the limit question is 0.5, and this is based on the L'Hopital method question. So this is very easy question. So we proceed the next question. So we get another question. So this is also a memory based question. So we have to given that f of x is equal to 1 plus 1 plus e to the power minus x, we have to find out f dash x value at f of x is equal to 0.4. So we have to simply f of x, we have to given that 1 by 1 plus e of minus x, means we have to write this way 1 plus 1 by e of x, means we have to write this e of x 1 plus e of x. So we have to find the values of e of x over here. So if we put the f of x value 0.4 over there, so 0.4 is equal to e of x upon 1 plus e of x. So we have to get 0.4 plus 0.4 into e of x is equal to e of x. So if we substitute the value 0.6, e of x is equal to 0.4. So e of x value 0.4 upon 0.6 means 2 upon 3. Then we have to find out the f of x. So for f of x, finding out the f of x, we get f dash x. So first time of derivative of these terms is we get 1 plus e of x square. So 1 plus e of x into the first time derivative of e of x is e of x minus e of x, in some constant value we get 0, and e of x value is e of x. So if we multiply these two terms is cancelled out, so we get e of x upon e of 1 plus e of x whole square. So we get the values of e of x is 2 by 3. So we get 2 by 3 upon 1 plus 2 by 3 the whole square. So we get 2 by 3 upon 5 by 3 means 5 by 3 means 25 by 9. So we get 2 by 3 into 9 by 25. So we get 6 by 25. 6 by 25 means approximately 0.24 is the answer of the question. So the answer of the given question is 0.25. So we get another question that if x is a exponential random function, so exponential random function we can write known that the exponential random function means and means mean is mean is 1 by lambda and variance is 1 by lambda square. So this is the basic we have to know. So we have to find it out the values of lambda in the given expression. So 5 expected values of x is equal to variance of x. So we know that expect 5 e of x value is 1 by lambda and variance values is 1 by lambda square. So we have substitute these values and calculate 5 of 1 by lambda is equal to 1 by lambda square. So 5 equal to 1 by lambda. So 5 lambda is equal to 1. So lambda value is 1 by 5 for 0.2. This is a very simple question. Then we came upon a linear algebra question. So we are given a matrix 1 2 3 3 1 3 4 1 6. This is a 3 cross 3 matrix. So we have to find out the determinants of m square plus 12. So first we have to find out the determinant of this matrix. So 1 3 4 2 1 3 3 3 6. So we can check this is a if this is getting any relation. So if we check that one row 1 and row 2 we get row 3 value. So 1 plus 3 4, 2 plus 1 is 3, 3 plus 3 is 6. So we get the values. So this is the dependency present that r1 plus r2 we get r3. So the determinant values of this is 0. So we have to calculate the determinant values of m square plus 12. So if we check, so determinant of m square plus 12, so we get the determinant of m the whole square plus 12. So we get the determinant values over here is 0. So 0 square plus 12 we get 12. 12 is the answer of the given question. So we have to find out and we have to check if there is any relation present. If there is a relation present, then we have to get that determinant values as 0. So the answer of the given question is 12. So we get another question related to the we get another question related to the linear algebra. So there is another matrix is present and m is equal to u transform, and there is which a 5 eigenvalues is given. So we have to find it out the values of the summations of the values of the eigenvalue. So the relation is given m is equal to u transfer. So we get here we get the five matrices. So we if we take the one two cross one matrices. So if we transpose this ab, so if we calculate these two, so we get a square ab b square. So if we find it out the eigenvalue, so eigenvalues is a square and b square, so the diagonal element. So we can find that the trace of the matrices is equal to the trace of the UU transfer. So from that we have to get that the trace of UU transfer is diagonal element square. So we get 1 square plus 2 square plus 3 square up to 5 square. So we can get the basic formula n into n plus 1 into 2n plus 1 upon 6. So if we put the values of n over 5 over here, so we get the answer. So we get 5 into 6 into 11 upon 6. So answer of the given question is 11. So these all are the memory based questions. We are conducting this type of session again. So thanks for watching. If you like this type of content, please like, share, subscribe to our channel.